Hi, my name is Bhumanand Barik and welcome to my YouTube channel. Today we will be discussing about one more algorithm, that is logistic regression. Logistic regression is basically used for classification problem. It could be binary classification, it could be multi-class classification. So first we need to understand here what is classification. Classification means some amount of data points are present. In that data point we have to classify, this is a separate part, this is one more separate part. We have to classify, it belongs to A, it belongs to B, like this. We are not defining any other option. We are choosing from the option whether it belongs to A or whether it belongs to B. If there are four options, it could be called as multi-class classification. Like if it is like A, B, C, D, there are four options are present. So in that four options, if we are classifying it into four options, if it is A, it belongs to a separate option. If it is B, one more option, C, one more option, D, one more option. We are not giving it, it is present. Suppose the data set is present and one column is there in that data set, or one column is there in that data set. That column is having these four options, and from those four options, while calculating, we are calculating whether it belongs to like option A or option B or option C or option D. We are classifying in this situation. If we consider about like binary classification means two classification, either yes or no. Suppose there is a data set. In that data set, we can consider, like in that data set there are two options, like one column is there and that output column is having two options, yes or no, yes or no, yes or no. So some 1 lakh records are present in that data set. So out of those 1 lakh record, how many, there are some yes present and some no present. We have to classify when the new data comes whether it belongs to yes category or whether it belongs to no category. Suppose it is a obesity data set, weight, we are receiving weight as input, and out of those weight we are classifying whether the person is having fatness or not. Fatness means obesity. So if a certain value of weight is there, and like the weight is under that particular value, suppose 65 or 75 or 80, under that if a person is there, then he will be considered not obese. If it is more than that, if a person is 85 or 90 kg, in that situation we can consider it as obese, or obesity is present there for that person. So this is what called classification. So in this situation, if obesity is there, then it is yes. If it is not there, it is no. Yes or no, yes or no. This classification we are doing in this logistic regression, and we will get into the in depth of this algorithm. So suppose a bank is there, bank is having some 10 lakhs record. Out of those 10 lakh record, it has to be trained, the model will be trained, and the model will be created in such a way so that it can understand whether the loan has to be given or the loan should not be given. Yes or no? Yes, the loan has to be given. Yes, no, the loan should not be given. So suppose out of those 10 lakh records, 1000 people are only getting the loan and rest of the people are not getting loan. Here in the output column we can specify yes for the people those who are getting loan and no for the people those who are not getting loan, and the model can understand from the new data whether the person should receive the loan or not. So in this way the classification helps, and this logistic regression is specially used for binary classification and multi-class classification. As classification is being done here, still we are using regression word in the algorithm, and that we need to understand why regression while the classification is happening in this particular algorithm. So let's continue with it. As we have seen, logistic regression is used for binary classification and multi-class classification. So we can see here binary classification, like the value is yes or no. So when we are doing we are bifurcating between yes and no, that time what we need to understand, like here earlier in regression we used to find the best fit line. Here how do we find the best fit line? If we are simply putting a best fit line or a simple linear regression kind of line, then how do we classify which one is yes, which one is no, or how do we separate between two labels? That we need to see here. As we can see on the screen, this x-axis is for weight feature and this y-axis is for obese feature. So if suppose we are identifying a point where the weightage is 75 kg, so if the corresponding line which on the y-axis pertaining to x for this 75 kg, if we are finding this area, so anything above this line will be something like obese, or anything below this point will be something like not obese. So if a value is 65 kg, definitely it will fall under this category, under this line in y-axis. So this place is not obese. If the value is 80, so obviously it will fall after this point, this point. This is known as obese. Obese means the person belongs to fatty person, or the fatness is higher in that we can consider. So this method, finding a best fit line and identifying its respective y and classifying it to yes, no, 1, 0, mathematically if we say 1 or 0, 1 means yes, 0 means no. So searching for such kind of such kind of label in using linear regression is quite possible here. Then the question is, why are we using logistic regression? So suppose here we are considering a value which is quite higher. Suppose here the value which is something like we are having suppose the data points are present here, and in the data point some 10 kg to 100 kg people are here. In that we found 500 kg, while there is no person with the weightage of 500 kg, or this only 500 kg only data is present which is 500 kg. Suppose there are some 10,000 records are present in the data set. In the 10,000 records we can find so many weightages of 10 kg to 100 kg, but only one data is found which is of 500 kg, only one record. Even though this is one record, this can impact our data set, which is known as outlier in data science or statistical term. So this outlier can create a high level of impact on our data set while calculating. So let's check how this outlier is impacting. As we can see on the screen, this was our old line, old best fit line, because of this many data which is under 100 and all our data present under 100. So this was our best fit line earlier. But when this 500 came, 500 new data came, or 500 when we are considering this 500 only one data, that time if we are searching for our best fit line, this new line becomes our best fit line. So when this new line becomes our best fit line, so definitely the value which was considering as suppose 75 here, if we extend the value here, the value is something like more than 300 or some 380, something like that, 380. So now 380 kg is the value which is the benchmark for being obese. So earlier when a person was in the weightage of 90 kg, it was considered like obese. Now if a person is in the age of like in the weightage of 200, then also this 200 weightage person is not considered as obese, because our benchmark has been changed. And how this changed? This changed just because of this only particular data 500. So this is the data. If it is taken from the data set, then everything can be alright. So this outlier has to be managed first. So when this outlier comes, because of this outlier, this this linear regression did not work. So in this situation, a different kind of mathematics was required, which is known as logistic regression, in which log loss function is used just to convert the data from like 0 to 1. Like here, as we can see, our value was something in between 0 to 100. Now when this 500 enter, our value turned into 200, like 380, like something like 380, which is too higher, which is extremely higher, so which did not work for our data set. So in this scenario, what we can say, in this scenario, logistic regression was introduced, in which all the values are present between 0 to 1. So this 0 to 1 conversion is made by using sigmoid function. So I can tell you the explanation of sigmoid function, how sigmoid function works. What is sigmoid function? Sigmoid function is something like this, and the representation is something like, it's something like this curve is known as sigmoid curve, sigmoid function, and the range is between 0 to 1. Because if we can check the data set, if we see the data set, like the data set would be like this. It means either the data will be present with 0 value, or it will present with 1 value. There is no other value. Out of 0 and 1, we have to choose whether the data belongs to 1 or whether the data belongs to 0. That we need to check. This is what happens in logistic regression, or known as binary classification. So let's check how this function works. Here the sigmoid function y equal to f of x. So what is this function is? The function f of x is like 1 by 1 plus e to the power minus z. And what z is denoted? This z is omega t, it is something like w transpose of x plus b. What is this w transpose of x plus b? That I'll tell you. We can write similar kind of function like e to the power w transpose of x plus b divided by 1 plus e to the power w transpose of x plus b. So this both functions are equal. Like if we simplify this, again it will turn into like 1 by 1 plus e to the power minus w transpose of x plus b. You can see on this. If you divide the like numerator and denominator, with e to the power w transpose of x plus b, it will simply turn into this value. Both are same. So this is what our sigmoid function is. What this sigmoid function does, this sigmoid function especially turns the value from between 0 to 1. It means whatever the value is there, if it is 200, 500, like 2, 3, minus 4, whatever the value is there, this value will be turned between 0 to 1. There is no other value less than 0, there is no other value more than 1. So entire value will be turned from 0 to 1. But the question is here, what is that value? How do we find that value? And how that value is calculated? Once we understand how the value is calculated, then we can simply implement this log-loss function, and it can turn into this sigmoid function will be implemented, and the value will be turned from 0 to 1. So let's understand how that value is calculated. As we know, in linear regression, the linear equation is mx plus c, where m is the slope, x is the x value, c is the intercept, y intercept. This is y, this is x. Where the c is touching the y axis, that intercept is known as where the line is touching the y axis, that value is known as c. So c is here touching 0, so c is 0, so it means like the value is mx only. And this line can be simply written with the form like w transpose of x plus b. So here b is the y intercept and w transpose of x. What is x value? That we know. So w is the weight. So now let's understand how to find that z value. That z we have considered in the sigmoid function. How to find that z value, that we need to understand. So what is w transpose of x? W transpose of x is simply the distance of the point from the best fit line. So here, if we see, we found this best fit line. There are some points here. These points are present. I'm talking about linear regression, like linear equation I'm talking. In linear regression, we used to put a best fit line like this. So how that best fit line is helpful in logistic regression, that we are trying to understand, because logistic regression is used for classification. So if we are using regression formula for identifying a classification problem, then that we need to understand how the regression is converted into classification. So that we need to understand here, because on the x-axis, and this is what the w is. This is what called w2x. This is what called w2x. Let me clear here. Logistic regression is used while we are able to linearly classify some data points. It means linearly classify means there are some data points. Those data points can be classified just by putting a linear line. By putting a line, we will be able to classify both the data. Those kind of data is known as linearly classified data. So here we are focusing on that kind of data which we are able to linearly classify. In this data, suppose we found the distance, but how do we know it is properly classified or incorrectly classified? That also we need to understand, because the loss function is something like summation of I equal to 1 to n w transpose of x. And as we have considered b equal to 0, because b is cross touching 0 point here, so we are not considering that one. So which is our y value? So here what we need to understand is we need to understand the points for which we found the distance, whether the point is classified properly, correctly, or whether it is classified incorrectly. That we need to understand. Suppose I can say, suppose a point should be considered as 1, and now that point is present here, and the point which should be considered like 0, that point is considered here. So or if the point should be considered as 0, it is point placed here, and the point which must be considered as 1, it is placed here. This side only 1 1 1, this side only 0 0 0 0 0 means let me change the color, like 0 0 0. So this side 0 value must be there, this side 1 value must be there, but here there is a point which is placed at the 1 side, and these are the points which are placed 0 side. It means those points are incorrectly classified. How do we know that? That is known by multiplying y value with WTX. So let's check how that formula works. So let me make it clear. The values which are present at the upside of the ascending line, the line is ascending here, increasing. So if it is present this side, it means these are positive value. If the data points are present here, these are negative value. So y is positive, or y is positive if it is present here. Y is negative if it is present here. So similarly, the distance is positive. The WTX distance is positive if it is present at this side, and that value is negative if it is present this side. Now we need to understand, how do we know whether it is correctly classified or incorrectly classified? For that, the formula works like y into WTX. If y into WTX, y multiplied with WTX, is positive, it means it is correctly classified. If it is not positive, if it is negative, then it is incorrectly classified. This is incorrectly classified. This is positive, correctly classified. If it is 0 or if it is 1, whatever the value is there, but if y into WTX is positive, then it is correct. Whatever, if the classification says the value is 0, then not an issue. But internally, the algorithm should understand this y into WTX must be positive, then only it is correctly classified. If it is considering the multiplication is negative, then that is known as incorrect classification. Let's check how it is happening in mathematics. If y is positive and WTX again positive, then y into WTX equal to positive. If suppose y equal to negative and WTX also negative, then negative into negative, again y WTX equal to positive. So in both the condition, even if y is positive or y is negative, in both the condition y into WTX becomes positive. So it means it is correctly classified. If y is negative and WTX is positive, that time the multiplication becomes y into WTX equal to negative. It means incorrect classification. Or vice versa, it is positive, WTX is negative, it is negative. It means incorrectly classification. So suppose the value is present here, for which WTX equal to negative, but we got that respective Y value is given for that is positive. So positive into negative means it is negative, incorrectly classified. Positive means data says the value must be present here, but actually the data is present here. The calculation says the value must be present here, actually the data is present here. It means incorrectly classified. Similarly, WTX is positive, but Y value is given for that is negative. It means in data it is present here, but calculation says it is present here. So in such scenario it is incorrectly classified. So how do we deal with that? How do we deal with that? We are dealing with all these equation by making a summation, because here the formula is max of summation of I equal to 1 to n y WTX. The max value we have to take, and this max value we have to proceed with further sigmoid function. So how do we check that? How do we calculate the max value? We have to make the summation, and maximum value we have to consider. So here suppose there are data points, and those data points are linearly classified. Now it is linearly classified. This is proper classification. We can see there are few data points which are present with the distance of 2 all. Suppose as an example I am taking all the data points as same distance, like each data point is present with the distance of 2, and here all these data points are present with the distance of 2. Negative side, this is positive side, sorry, this is negative side, and this is positive side. Let's understand how it works. Now what I can see, suppose there is a outlier present in that outlier. If the data is like this, it is properly classified. Suppose we are introducing an outlier. The outlier is here, 400. The distance is 400, and this is negative 400. How it works? Let's see. Here the calculation says the formula is -2 into -1. Again this is -2, -2, -2, -2, 4, 5 -2 is there. Here also +2, +2, +2, 5 +2 are there. So there are total 5 -2 and 5 +2 are there. So if we check here, and one -400 is there, -400 is there. So we have to multiply with respective y. For these many data points, y is negative, so it will turn ultimately like 2 + 2 + 2 + 2, like this 5 2's. For these two, y is positive. It means again these are 2 + 2 + 2 + 2 + 2. So but this is present this side. for this y is positive, y is positive, y is positive, it means minus 400, because minus, this is minus negative, sorry, minus WTX into plus y plus positive, so it is minus 400. It turned into something like 20 minus 400. I'll explain you. So it is something like 20 minus 400 equal to 380 minus 380. Now this minus 380 is a very big number. We need to understand. So as we can see here, the line is coming as minus 380. Minus 380 means we have to here from here onwards, somehow we have to put a line some here onwards, like this. A line has to be drawn, not in this line. This line doesn't fit while 400 is present, so this line is incorrect line, it becomes incorrect line. Now let's check what will be our best fit line. Suppose as I told, we have to consider the maximum value, so we need to search what are the other lines which are able to form. There could be, this could be other line, and this could be other line, this could be other line, this could be other line, there, this could be other line, and this could be other line. So whether this line has to be taken as best fit line, this is best fit line, or this is best fit line, or this is best fit line, or this is best fit line, which line we need to consider. So for each line, this summation of I equal to 1 up to n y w t x value has to be considered, and which line is having maximum value, that value we have to consider. So let's check another line for which the value could be different. So suppose take this line. If we take this line, how the distance is calculated? Again draw this. I'll draw this again, because minus 380 is quite negative value, and we can find so many values which are higher than minus 380. So which value will be highest value, that value we have to consider for the best fit line. Here you can understand how are we implementing regression method just to identify classification, or just to implement in classification problem. So suppose this is the line, this is the linearly separable line. Here 400 is present, and the distance of 400 is negative 2. Some other lines are present the way I have drawn earlier. So now the value of the distance of this line, the distance of this particular point is suppose minus 6, and this is minus 5, minus 4, minus 3, and this is plus 6, plus 5, plus 4, plus 3. So if we implement our y into WTX formula, it is simply minus 6 into y. Minus 6 here wrongly classified, minus 6 is here wrongly classified, so we can consider here like minus 6 is above the line, sorry, it is above the line. If it is above the line, it is multiplied with plus 1, because plus y I am multiplying plus 1. Here we are considering y equal to plus 1 if it is above the line, y equal to minus 1 if it is below the line. That we are considering here. So if y is multiplied plus y is plus 1, y is multiplied with minus 6, it turns into minus 6 again. So like that, minus 6, minus 5, minus 4, minus 3, those are above the line. So minus 6, minus 5, minus 4, minus 3. This 6 is above the line. So 6 into plus 1 again, because this is also above the line. These are above the line, these points are above the line. This is the only value which is below the line. So we can consider 6 plus 5 plus 4 plus 3. Now what is this value? This value is minus 2. Minus 2, and this is below the line, minus 1 plus minus 2 into minus 1. This will be again 2. So this 6 5 5 4 4 3 3, this became cancelled. The only value is remaining, that is 2. So if we calculate the value, simply if we calculate the value, it becomes 2. This is the maximum value which we are getting. Suppose there are other lines also. If we keep on drawing the line, and if we keep on identifying different values, implementing this like formula, suppose we are getting, this is the highest value, 2 is the highest value we got, and 2 is definitely higher value than minus 380 or minus 320, something like that. Whatever the minus value or 1, whatever the value is there, 2 is the highest among them. So this 2 value has to be considered as our updated weight. So this updated value is 2, and now this 2 will be converted into 0 to 1. This 2 must have a value between 0 to 1. And how this will be considered, that I'll tell you. Here simply implemented y w transpose x formula, and this y w transpose x is known as z, and this z is applied to sigmoid function 1 plus 1 by 1 plus e to the power minus of z. Here in z value, this y w transpose x will be kept. Now what happens? We know y value, we know x value. The only thing we know so as we have discussed how this like WTX value is found, and this WTX value is passed through sigmoid function 1 by 1 plus e to the power WTX y WTX. This is minus, and this value turns from 0 to 1. So whatever the outlier is present, whatever the value is there, it won't increase or decrease the value. Ultimately it will like cut the value between 0 to 1. So impact of outlier is not much important here in classification. So ultimately we are getting our output, whether it belongs to 1 or whether it belongs to 0. So classification is done properly using this method. Now one more concept we need to understand: why the name came like logistic. Logistic means there is a function called logit function or log loss function. We know here we are implementing this sigmoid function e to the power WTX plus b divided by 1 plus e to the power WTX plus b. This is what, or similarly it is equal to like 1 plus e to the power minus wtx plus b. Both are same. Here one thing we need to understand, the log loss function is used. What is log loss function? Log loss function is logarithm of the probability of the event is occurring divided by probability of event is not occurring. Ultimately it is, I can 1 minus again e to the power wtx plus b divided 1 plus e to the power wtx plus b. This is, and if you solve it, it will be wtx. How it happens? That I'll tell you. The formula will give you the result something like log of epsilon of wtx plus b. So if log is outside and epsilon is inside, so it is log of e. Ultimately it will be wtx plus b. As we are considering b equal to 0, it will be wt of x. So ultimately we are finding wt of x. So if this log loss function is used for identifying this wtx, and that's why we are implementing, we are like calling this function or calling this algorithm as logistic regression. Hope you have enjoyed this video and you have liked it. If you like this video, then share it and subscribe my channel, as well as I will be explaining about multinomial classification in the next video. Multinomial classification or multi-class classification, so in which we can find A, B, C, D, like that. There will be 4 or 5 options, out of which we have to choose whether the data belongs to A category or B category or C category or D category. Ultimately more than 2 categories are present, which is not binary classification, which comes in multinomial classification. Okay, thank you so much.